Good day, my students. You are welcome to the series of lessons organized by the foremost publisher, University Press, PLC. The lessons are designed to empower you to face the forthcoming examinations conducted by WAEC and NECO. My name is Akanbi Sunday Olusegun. You are welcome. Thank you. Last lesson, we discussed quadratic functions and quadratic equation. We will continue by giving more examples and by look at applications, that is problems leading to quadratic equation and how to solve them. As I was saying the other time, the textbook we are using is Mathematics for Senior Secondary School. The one on my hand is for SS3. We still have another series for SS2, SS1. SS2, SS3 and SS1 textbook of this form is the one we'll be referring to, because majority of the word numeric examples there are taken from past questions. Thank you. Now let's continue. The other time I was discussing how to solve quadratic equations by factorization method by use of quadratic formula. Now we will look at another one, that is completing the square method. The textbooks here, if you look at page 325, 324, there's a model question there by WAEC. Page 325, questions 12 and then question 12 at 9. But I'm going to work them later. But let's discuss completing the square method. Question 9 is saying solve using completing the square method. Mamas, the textbook I showed you the other time. Solve 3p squared minus 5p plus 2 equals 0 using completing the square method. Here the question says using completing the square method. You are not supposed to factorize. It is factorizable. It has rational factors. You are not supposed to use formula, and you are not supposed to use graphical method. The question says solve using completing the square method. So the method you are supposed to use is specified. Solution. Let's look at solution. I write it, that is by solution. 3p squared minus 5p plus 2 equals 0. The first step, step 1. Transfer the constant term to the other side. Transfer the constant term to the other side. That is 3p squared minus 5p equals minus 2. That's the first step. The second step, divide through by coefficient of p squared. Please take note. This is quadratic equation in P. Please, you are used to X, but this one is now quadratic equation. The variable is P. Divide through by coefficient of P squared. That is by 3. Step 2. 3p squared minus 5p equals minus 2. When you divide through by this one will be over 3. This one will be over 3. This one will be over 3. That is, we have p raised to power 2 minus 5p over 3 minus equals minus 2/3. Please take note. Do not write 5/5p/3. This is wrong. Do not write minus 2/3. We don't accept this again. Computer term, we don't accept it. Slash. Now, from here, step 3. Step 3. Step 3, find half of coefficient of p. Please take note. Find half of coefficient of p. You know, coefficient of p is minus 5/3. Find half of coefficient of p, then square it. Half of, that is minus 5/3. Half of it is times half. Minus 5/3 multiplied by half, all squared. That is 25/36. Half of coefficient of p. The coefficient of p here is minus 5/3. Half of it is minus 5/6. Then square it. It will be 25/36. Step 4. The fourth step. Step 4. Add to both sides. Add to both sides. To both sides of p squared minus 5p/3 equals minus 2/3. Add to both sides of this one 25/36 of this 25/36. That is p raised to power 2 minus 5p/3 plus 25/36 is the same thing as minus 2/3 plus 25/36. Again, half of coefficient of this is minus 5/6. Square it, 25/36. Add to both sides that value. You are not doing anything strange. You are not committing any offense. 25/36 is here. 25/36 is here. You are adding to both sides. Then it becomes p squared it becomes p squared minus 5p all over 3 plus 25 over 36. This is the same thing as minus 2/3 plus 25 all over 36. If you look at this, this is a perfect square. This is a perfect square. The reason is this. Let me show you something. You will discover that this is p raised to power 2. This is 25 over 36. When you have something like this, x, when you have note, let's say you have x squared minus 4x plus 4. This is the same thing as x plus 2 all squared. Why? You know, half of this is this all squared. When you double this, you get this. So this one becomes what? P minus 5 over 6 all squared. Please, I want to do something here, because I don't want you to think that I'm doing magic. If you expand this, it will be the first one squared plus this one squared minus twice of this. Twice of this is 5 over 3. So in effect, this one becomes P minus 5 over 6 all squared. This is the same thing as minus 2/3 plus 25 over 36. Minus 2/3 plus 25 over 36. Simplify this. The LCM is 36. This is the same thing as 25 minus 24. I'm very sure you'll be wondering why, how. I did plus before minus. 36 and 36, 1 times 25, 25. Because I don't want you to manhandle board mass. Yeah, I know some of you will say plus, minus and plus. Write this one before this, and you get this. Remember our GSS2 topic. Now, this is the same thing as 1 over 36. P minus 5 over 6, all squared. I don't want to waste. This equals 1 over 36. Please look up. This is a perfect square. Do you know that this one is also a perfect square? This is the same thing as 1 over 6 all squared. Compare the two. Find the square root of both sides. Find square root of both sides. P minus, the square root disappeared. You have P minus 5 over 6. That equals 1 over 6 plus and minus. The square root of 4 plus and minus 2. Now from here, P equals 5 over 6 plus and minus 1 over 6. You transfer this one to the other side. This is the same thing as 5 plus 1 over 6, which is 1, and 5 over 6 minus 1 over 6, that is 2/3. Please, I want to advise you, this is not Becker exam. You are potential university undergraduate this year, so you don't need to say you find the answer. You are wasting your time at this stage. You have to know that when you had 5 over 6 and 1 over 6, the answer is 1. And 5 over 6 minus 1 over 6 is 4 over 6, which is 2/3. P is 1 and P is 2/3. For Christ's sake, do not change this one to decimal. If you change 2/3 to decimal, you get 0.667, and it's not equal to this. Now let's go to how marks are awarded. If that question is attract 6 marks. Now, I said step 1. For the first step, say transfer the constant time to the other side. No mark for that one. If you like, you can leave it there, but you are going to get another expression. Then the second step, divide through by 3. You are making the coefficient of p square a unit, that is 1. They give you B1. B1. There is a bonus of 1 mark. Also, by finding half of coefficient of p and square it, we want to see this 25 over 36 somewhere. You must write it. To tell us that you are finding half of coefficient of p and you are squaring it, you will be given another bonus of 1 mark. Whether you are adding or you are doing this, they give you 1. For identifying that this expression is a perfect square, they give you another bonus mark. Another bonus, that is 3 marks. For equating, for saying this minus this is equal to this one, they say, okay, M1 for isolating P. Then, for saying P is 5 over 6 plus or minus 1 over 6, A1. And for saying P is 1 and P is 2/3, another A1. Please, P is 1. If you use or, well, you may be pardoned, but the word or, please try to avoid it, because you are looking for 2 values. If you say A or B, I'm not an English teacher, but if you say A or B, it means you are looking for only one, either this or this. But this and this is quadratic equation. This is completing the squared method. Please do not say because it is very easy to factorize, you factor it out. You will miss the method mark. The first bonus mark will be 0, because we want you to find half of coefficient of p, but it is not, we didn't see it. You get the bonus mark of 0. For the other one here, get it to perfect squares. If it is not there, it's a M0. M0. If you look at the final stage, it looks like a quadratic formula. But those but it looks like I can say P is equal to minus B. No. That is completing the squared method. They want to see that this is equal to this. And you know this is a perfect square, this is a perfect square. You find the square root of both sides, and that gives you the answer. Now, that's quadratic equations. Let's quickly move to quadratic functions. Quadratic function. Quadratic function. I told you this book is of immense value to us. Honestly, those of you preparing for UTME, either pre or post, if you go to page 324 and pages, in fact plenty, pages 161, 162, 163 and so on. Quadratic functions. This is a new, more or less a new topic, but it's not new. It's not new. It's still under quadratic. But before then, when you have equation of this type, ax squared plus bx plus c equals 0, I told you the values of x are minus b plus and minus the square root of b squared minus 4ac. Please take note. Everything all over 2a. Please note. B squared minus 4ac is called discriminant. 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 Not determinant. Discriminant. It determines the nature of roots. The nature or how the roots behave. How the roots behaves. What I mean is this. Number one, if the discriminant b squared minus 4ac, if that discriminant is 0, the roots are real and equal. Real and equal roots. And equal roots. E.g. x squared minus 6x plus 9 equals 0. And so on. I will give you the diagram. The diagrams are here because I don't want to waste your time. But let me just give you the diagram of one. Look at something like this. When you have graph that looks like this, real and equal roots. Real, the y-axis is here, the x-axis, the origin, the negative x-axis, and the negative y-axis. When it looks like this, you have real and equal roots. Or
negative minus what
you minus real and equal roots, or there's another word we normally use for it, or perfect squares. Perfect squares. Perfect squares. Because then they give you a question for what value of x, for what value of this or that is this question has equal roots or perfect square. When the discriminant is 0. Then another one. When the discriminant, when b squared is more than 4ac, it has real and unequal roots. Real and unequal. Unequal roots. E.g. x squared minus x minus 12 equals 0. Now the third one, I will draw a diagram for that one. I will draw diagram for that one. That is x squared minus x minus 12 equals 0. When you have something like this, let's say this is minus 4, this is 3, this is minus 12. Y, negative x, positive x, negative y. You see that the roots are minus 4 and 3. They are unequal. They are unequal. The last one, if the discriminants are minus 4ac, if the discriminant, that is b squared minus 4ac, is negative, you have imaginary roots. Imaginary. That means you can't solve it on a real line. It is not possible. You can't solve it. The graph of that type looks like this. When you have a graph that looks like this, it doesn't cut the x-axis. Or something like this. You can't find values of x. You can't find the roots. That is imaginary root. I will give you an example. You know, I say when the discriminant is negative, that is less than 0. For example, let's say you have something like this. X squared plus x plus 7 equals 0. If you are a magician, you can't solve this equation. It is not possible. It's not possible. Because b is 1. B squared is 1. A 4a is 4 times 1 times 7. So 1 is less than 28. This one will give you imaginary roots. Anytime you are dealing with, you can't find it in this book, because there are some questions in this book you are using where the solution is imaginary. That is why you continue working and you will never get it. But it is not in this book, because the book is made and authored and revised by mathematicians. We can't give you this type of question because you are not operating on imaginary feed. Let's look at one example here. It's in page 163. The question says, but before I leave this, let me show you how to undo questions that look like quadratic functions. A question was here. Check. Why can echo question about 3 years ago? This type of question was given. The question looks like this. They said this one minus 2, this one 5, and they say y, negative a, and the question says why this is cos y equal to as squared plus bx plus c. The question says find a, b, and c. That is the question. That here. I don't want to waste your time. When a quadratic equation is given and there are unknowns, there is a way of forming quadratic equation. The rules they want you to use is how to form a quadratic equation. Note, a quadratic equation, roots alpha and beta. The equation is given by x raised to power 2 minus alpha plus beta. Don't worry, x plus alpha beta equals 0. I will write it in a layman's language. That is, the equation is x raised to power 2 minus, in brackets, sum of roots multiplied by x plus product of roots, and everything equals 0. This is what I'm saying. In this case, they just gave it's very common. That is why I will advise you to get books 2 and 3. It's so that it will prepare in UTME, other post or pre. They just give the diagram like they say find A, B, and C. I will do this one. You see how simple and how they want to catch you. Then the first thing, the roots are minus 2 and 5. Sum of roots minus 2 plus 5, and that is 3. Product of roots minus 2 multiplied by 5, that is minus 10. If you go by this rule, the equation is x raised to power 2 minus sum. What is the sum? 3. X plus product. What product? Minus 10. Everything equals 0. You don't leave it like this. You simplify. X raised to power 2 minus 3x minus 10 equals 0. That is the equation. If you want to write it in this form, this is the same thing as x raised to power 2 minus 3x minus 10 equivalent to ax squared plus bx plus c. You know, I told you this equivalent. It means coefficient of s squared is coefficient of s squared. Coefficient of this is this. The constant term is the constant term here. From here, 1s squared equivalent to as squared. Therefore, a is minus 3x is the same thing as bx. It means b is equal to minus 3. The constant term is minus 10. That means c is minus 10. I don't want to waste your time on that. Let's continue. For, you know, the other time I said, how are they going to assess you here? Because some of you may just look somewhere and you write this, you just write this one down. You are A and B, probably you, or you just look at the diagram and you put it down. No. For getting the sum of the roots, they give you 1 mark. For getting, that is why it is very easy to score almost everything in mathematics. For getting the product, which even someone in primary school can get, they give you another bonus mark. For substituting from the rules, they give you M1. There is a complete method map. For getting the equation A1. Now, for getting A1, A is equal to 1, B is minus 3, C is 10. They will say A2. Please, this is very important. They will say A2 minus 1 for each error. Again, 2 marks, but minus 1. You know, we have 3. 1, 2, 3. If you get all the 3, they give you 2 marks. If you miss this one, they will say minus 1. If you miss this one, minus 1. But if you miss all the 3, they will not say minus 3. The maximum penalty there is 2. Because it is 2 marks, you cannot get minus. So if you miss 2, it is A2 minus 2. Now, I have one very interesting question here, which I want us to look at. Is question in this book. Please, I want you to go and get it. This is wire questions 1 year, page 324, 12A. That's number 12A. The question says the root is given 2x squared bracket p plus 1s. I will write it down for you. There is something I want you to note. The roots of the equation. The root 2x squared plus p plus 1x, then they say plus q. 2x squared plus p plus 1x plus q equals 0. We are given the roots. I just want to look at it because I don't want to waste your time. 2x squared plus p plus 1x plus q, they say equals 0. It's past question. It's a very simple and a bonus. The question, I think, is very funny because it carries 7 marks. It carries 7 marks. They say the root of that equation are 1 and 3. 1. Roots are 1 and what? And 3. Then the question says find P and Q. Find P and Q. Because of our time, I only want you to see what they are saying. You remember the other time I gave you the formula. I said S squared. I said S squared plus sum of root, minus sum of root plus product equals 0. But if your mind flashes to that area, one may be, yes sir. Find P and Q. Thank you. Now, please, the roots are given. The roots are given 1 and 3. The roots, they are values of x, where the curve crosses x-axis. It means when x is 1 and when x is 3, this expression is equal to 0. When x is 1, substitute you get 2 into 1 raised to power 2 plus bracket p plus 1 multiplied by 1 plus q equals 0. That is 2. Please, this is 1 square. 2 is not affected. 2 plus p plus 1 plus q equals 0. This is a variable. This is another variable. Write them together. P plus q. 2 plus 1 equals 3. This is equal to, you know, 3 is on this side. When it goes to the other side, it becomes minus 3. Then when x is 3, when x is 3, you substitute for x because the value of x is one of the roots and is 3. Substitute, it will be 2 into 3 all raised to power 2 plus p plus 1 multiplied by s, which is 3, plus q equals 0. Simplify that one. 3 square is 9 times 2, that is 18, plus 3p plus 3. Please, you open this bracket, plus q equals 0. Now look up. This is a variable, this is a variable. Write them together. 3p plus q. 18 plus 3, 21. Take it to the other side. That is minus 21. Remember the first equation is p plus q, which is minus 3. My students, this one breaks down to simultaneous equations. We are not going to solve because you are adequately informed how to solve them. Finally, the last one, that is why I said I love this not because I'm a mathematician. I saw another question that interests me. The question is on 161 on problems. Don't call it problem. Exercises leading to quadratic equation. Page 164, page 160. The question is just how to apply quadratic equation. The question says, on a journey of 300 kilometers, the driver of a car observed that by reducing his actual speed by 10 kilometers per hour, he would take 25 minutes more to cover the whole journey. Yeah, I only want to put it on the board so that what I'm saying is on a journey of 300 kilometers, the driver of the vehicle calculates that if he reduces his average speed by 10 kilometers per hour. Now, this is the total journey, 300 kilometers. Please take note. This is what they want to test from you. They want you to know that time is distance over speed. Let the speed be s. To cover the whole journey, time will be total distance all over speed. If you reduce the speed by 10 kilometers per hour, reduce the speed by 10 kilometers per hour, time. When s is reduced by 10 kilometers per hour, now the speed becomes s minus 10. Please, finally, the time taken if is moving with the actual speed will be 300 over s. If the speed is reduced by 10 kilometers, you know that it will take longer time. The time taken there will be 300 over s minus 10. It will take longer time here than this. So the difference in the time, the question says it will take 25 minutes longer. So it will be 300 all over s minus 10 minus, because the time here will be more than this, minus 300 over s, and that will be the difference in time, 25 minutes. It's not kilometer per minute. We are talking of kilometers per hour. So 25 minutes is 5 over 25 minutes is 25 over 60, which is 5 over 12. 25 minutes, that's 25 over 60. So that is 5 over 12. This one becomes an equation, quadratic equation. By the time you cross multiply the fraction, you get quadratic equation. Take note, your speed can never be negative. It is not a vector quantity. Thank you. By the time you you clear the fractions, you will get quadratic equations. Please, this is very important in marking. This one is very funny. You get 1 mark here for s, this over s minus 10 b1. For finding the difference, the method mark. For getting your quadratic equation correctly, m1 a1. For solving that quadratic equation and get speed is not a vector quantity. It's a scalar quantity. It must be a negative, but you are getting 2 values because it's quadratic. Thank you very much. You pick the positive ones. For getting that speed, the unit must correct. Kilometer per hour. If you write kilometer per second, you get -1. If you write kilometer per minute, you get -1. Thank you. Meet you again.